2¼ inches. 2¼ inches. And now we've got a special, I don't want to say interruption, but John Wilburn has come up with an excellent idea. At least I think it's an excellent idea. And I thank you, John, for bringing me into the fold with this. I'm going to interrupt what I was doing with the other projects. And I do have the green block ready to mill, but there's a more important thing going on because time is getting, close to the end before everyone gets to the No Name Nationals. And Mopar Joe has a unit that he's running, and he's already testing on the track. And John thought perhaps he could give a shot at one of my spacer plates. So I've gone ahead through talking to John and an okay from Joe that I'm going to build a 2-inch spacer plate for Joe, and we'll try it on his car because he's not running a spacer plate at the moment. And what I'm going to also do with the spacer plate is include something that I was going to kind of throw out at the world later on, and that is some cooling items, kind of a built-in cooling situation for the spacer plate. We all know aluminum conducts heat and cold quickly and very well. So rather than trying to approach it from the point of the phenolic style spacers where they just insulate the carburetor, or try to, and of course you get a little transference of heat from the sorry I was interrupted there. That permanent visitor was outside, and I had to make sure that he was going to find the right way. Anyway, what we're going to do is not only give the volumetric capacity an increase of 2 inches through the spacer plate, I'm going to try to throw my own style of surface cooling to try to drop the temperature of, or allow the temperature of the manifold as it's coming up through the studs and through the manifold itself to cool off just underneath the base of the carburetor. And I think that's going to help help that condensation, help the atomization be more dense, and therefore allow him to get even more fuel down inside of that extended volumetric capacity. So what I'm going to do is show you a piece of metal. I had ordered this stock of aluminum, and it came in much bigger than I had ordered. My thanks to those folks who sent that, but it's too big for my milling machine. So what I'm going to do is take this over to Profile Machine Works over in Manassas and have them cut it down for me. And while it's there, I'm just going to have Martin, the machinist over there. It's a CNC machine shop, by the way. It's not an automotive machine shop. So hopefully he can do this for me. He'll cut that out, cut out the center, and I'll take the cut pieces home, and I will work on the cooling side of it on my machine. It'll be small enough for me to manipulate at that point. And there's enough stock left that I can make a 2-inch 2-barrel spacer plate. 318 will run, call your office, maybe? Let's see what happens. And let me show you the plate first. Alright, so here's the plate. As you can see, there's a huge amount of extra space here. So I'm going to have him save me all of this and all of this. Gosh, this alone is about 9.5, almost 10 inches long, and this is 6 inches. So the whole thing here is like 7.5 inches, which that would have been able to go on my machine. I'd have been able to handle that, but this I can't handle it. It's too big on my machine. So we'll see if Martin can cut that out for me. And I might even have him punch the holes. You know what the heck. I didn't use any layout fluid on this. I'll let him do it if he wants to do it. If not, then I'll bring it home and try to suffer. We'll see what I can do with my machine if Martin can't handle it. So, but I think he can. All right, so I'll take it over to the shop and see what happens. Thanks for watching. Hey gang, it's been a while. Sorry for the absence. Been very busy with a lot of things. So let's get right to it. The machine shop that I was going to try to use is now closed. When I got there, the gentleman who had run it for a number of years finally gave up. His health was kind of on the outs. Gave me a number of another shop to go to. So I called that number, left a message, and then when I didn't hear anything back, I immediately went over to that part of town and started to look for this place. It wasn't in the yellow pages online, so I was very curious. There was one in another town on another part of our state. Turns out he also had closed right over here and moved back up to that part of the state, which left only one machine shop in this entire, I don't know, from the Potomac River all the way probably down to Fredericksburg and back over to the valley. And the guy was slammed, and you would expect it. Now, this is not an automotive machine shop. It's a CNC machine shop where they handle custom stuff, and they actually do production work. If you've never been to a CNC machine shop, I suggest you try and visit it sometime and see what kind of work they do. So my request was really small potatoes to those guys, and their prices reflect that. And so in working with Just Mopar Joe, I told Joe, I said, look, I'm going to go back up there and just get this piece of aluminum, and I'm going to hack it myself. You know, so like an entry level, a decent entry level metal bandsaw costs a lot of money, and I don't do enough work to justify that with that kind of material. So I'm just going to go ahead, for the sake of saying that the metal just doesn't cost that much in front of these other expenses, cut this up myself. Now, that said, that gave Joe some time to make some, what I consider to be very important temperature readings inside of the engine compartment. And the reason why I say that is because this particular design that I have in mind is to help cool off the spacer and try to keep things evenly dispersed heat-wise. And I'm glad I waited before cutting this out, because it has changed my mind as to how I'm going to make this. If you watch his video, and I'll try to put a link to it in this one, you'll see that as he's measuring the temperature in the front of the engine, it's cooler than in the back of the engine. And strangely enough, even the fuel line was considerably warmer on the back bowl than it was on the front bowl. And obviously the air that's coming in the front of the engine, through the radiator and underneath the front of the car, is keeping everything much cooler. And it was even on a 100-degree day. And that also has a little bit to do, it's my understanding, of the fuel. So you got to watch the fuel and the specific gravity of the fuel. The lighter the fuel, the faster it's going to expand. And if it expands too fast, and it's got a longer way to go down to get into the cylinders, then it may be, you may be robbing yourself of some power. But another part of this problem is, why is that so cool up front and hot in the back? So we're going to try to deal with that. Hopefully I can help out anyway. Joe's a very smart guy. He knows exactly what he's doing. And I don't want to try to mix things up too badly for him. but we're going to give it a shot. So I'm going to change that little design you saw in my last video to give more meat to the back end, and there's a reason why, you'll see it. And I'm going to completely delete the cooling fins I was going to have on the front. The front doesn't need any more cooling. It's in the back that we need to do some more cooling. So let me do some of this work today, just do some cutting, and we'll just keep on going. I hear that tractor. That means work. Bye. Nice even speed. Nice even speed. Alright, so let's do a little check in here. And I know I got to go all the way through this, but really just giving myself a good idea about time. Let's see what we're doing here. So that's getting about, let's see what it is, almost a quarter-inch an hour. It's nice and slow, but you know what? I don't want to make any mistakes because I'm only buying one piece of aluminum. And what the hell? It is what it is, and I'm getting away with murder on this thing. Thanks for watching. See you next time. Hey, I'm back again. Although my videos may be a little few and far between these days, at least for some time, I just wanted to tell you that I haven't forgotten about everybody, and I'm certainly going to continue to try to work towards the conclusion up to the No Name Nationals. No, I don't have any screeching tire to put in front of the video right now. Things are, like I said, they're going to be a little few and far between, but I wanted to continue on the discussion from my designing my own particular spacer plates. And before I wanted to go into that, one has to remember, I left that arena of screeching tires and screaming down the road back in the late 80s. So I wanted to make sure I tried to pick up on some of the better things, or at least the best of the best, when it comes to covering things like induction systems. And I decided to pick up David Vizard's book on how to build horsepower, carburetors, and intake manifolds. And David goes through some fantastic information in this book. I don't care if you're even an experienced builder or just starting off with one of your grandfather's, ragged remnants of the muscle car era, or even one of the boats like this one, like I have. Got to read this, and he confirms things that we picked up on and thought of and worked with back in the 70s when it came to induction systems. And I'll show you that in a second. And with this car, you may remember my video where we had my 0 to 60 foot time. Take a look at this. This is our handy dandy stopwatch. Are you ready? Here we go. And go. Oh, look at that. And in David's book, he goes over how components like this create the ram effect. And he explains it. David also explains why you don't want the air passing straight into the carburetor or over it. You want it to be equalized in a single pressure zone, something that doesn't have fluctuations. So like I said, David Vizard's book it's real cheap insurance to protect and keep your machine running at optimum performance. So my hat's off to Mr. Vizard. Thank you. Now, as David Vizard talked about in his book, there were different styles of air cleaners because throughout the EPA regulations, as they were becoming increasingly more difficult to deal with, the size of the air cleaners changed. But this is a 1966 automobile, and the dimensions of this filter pretty much work to the same favor that David talks about in his book. So this would be like a stage 1 kind of advancement that actually does gain a few horsepower. Read his book. He talks about the different filament types and manufacturing. It makes a difference. So thank you, David Vizard. Now I'm going to go out and get some ice cream. See you next time. And here we are again on that abandoned entrance to an abandoned secret Air Force base, checking for that 60-foot time. But right now we just want to check the performance of our newly changed intake system. And here we go. It's still heavy. Now here we are, another day, another hot, humid morning. So it's about 90 degrees now. It's 11 o'clock, and according to my gizmo on the wall, it's a 75% relative humidity. It's so bad in here that the sweat is sweating. So my mini mill really doesn't like it when it gets this hot, and I do all the things I can do to not make it seize up. And one of the things I'm doing here, cutting out that throat, this is the rough cut, and I'm using a 1/2-inch drill. So I'm just punching down, but sharing the hole behind it. The reason why I'm doing that is that it allows the shavings a place to escape. Otherwise, if you were just drilling a hole, it might bind up, and you'd end up having to keep cleaning it out. So let's. This should be the last one. So I thought I'd just bring you guys up to speed. A little cutting fluid there, and we'll see what happens. If we can cut this thing, we'll all be cutthroats now. Are you ready? Here we go. Tighten up. My drill speed may be a little high. I already hear the bucking of the motor. This is going to be the last thing I was going to do with it today. It's just getting so hot out here. looking at the gauge, still got 2 inches to go here. So I think I'll just split the video and get back to the end. Okay, about ready to kick it off. There it goes. There we go. We're all now cutthroats. I bet this sucker's hot too. Ooh, yeah. All right. It's still heavy. Dang gone. With aluminum, it wouldn't be that heavy. All right, so the next stop is put my end mill back on and go back here and smooth that stuff out. Try to bring it into spec for 4150. Thanks for watching. Welcome back, and just like I said in the last video, we're going to do some cleaning up of the throat so we can move on to the other parts of this unit. So I'll just keep making passes on each side, and we'll come back when I've got that done. Alright, so there you go, one side down, and we'll be back, probably in a few days to show you the rest of that. Take care. Back again. I had a little problem today. Somehow I've lost my working glasses. You've seen them, the old Made in America black frame, military vintage glasses. Those are ones that I use specifically for these kinds of jobs. So that's a small crisis, but not the end of the world. And I wanted to make sure that you're updated. Throats cut, polished out. I'm about to do some registration drilling, making sure the mounting holes are correct. I'm going to try to make them as close as possible to the mounting carburetor, to where the carburetor mounts, because at 2 1/4 inch of material, you need to try to have them as right on the button as possible. So you may have remember seeing the oh heck, it's right here, that adapter plate that went on my Offenhauser 360 dual quad. So I used these holes to set up the registration for drilling the passageways for the studs. And I'll use this to check that too. What I'll do is I'll mount the 3-inch studs that I have on this and drop it through. If they're a little tight, I've got a ream that's a couple of decimal points larger than 5/16, and I can just kind of gently pop those up a little bit. But there you go. Thanks for watching, and see you next time. Crisis averted. We're back in the... Let's see, I got the wrong damn hat on. Gotta have the right hat for the job. Alright, let's take a look and see at some of those holes that I've registered. Got 2 of them in. Looks pretty good so far. Let's take a look. And here's another reason why you don't want to call it hoarding parts, but you don't throw away stuff even though you may not be using it, or maybe it had problems before. But there are things like this spacer plate that I talked about before. This is a good registration product that I can use, because that is the 4150 drill hole pattern. As you can see, we knocked them in there. I was at first about I don't know, 3/1000ths of an inch out. So I brought them both in together, and boom, there you go. So, and of course, like I said, if Joe has problems with that, I can use a ream. I got a ream. I'll send him or lend him. You know, what the hell. You might as well hang on to it. But otherwise, I'll just keep going. Okay, we're going to just keep on going. Once I get those holes finally fitted, I'll take my my AFB. I've got a mid-80s, like 1985 AFB, and I'll test fit it to make sure we can keep going forward. Thanks for checking in. See you next time. And welcome back. Today we'll take a look at registering those back holes. I know some folks are always saying, how do you know how to set those holes up? And quite frankly, if you try to take the measurements off of the Holley website, say, just using their example as an example, I'm not the greatest mathematician in the world, but I tried the hypotenuse and the doodad and the whatchamacallit, and that squared plus this squared equals the square root of that. And that didn't quite come out right. It was close. Close isn't good enough. So somebody else did that work a long time ago. Remember I talked about the saving of old parts. Well, that's why I saved that part, because that's going to help keep us right where we need to be. And next I'll just show you how I'm setting up the back holes to make sure I don't run into that problem of being about 3/1000ths out as I was with the front ones. So let's take a look at that and get moving. So what I've got here is the longer studs are in the front of the holes that I drilled, and they're fit just right. And then I have shorter studs that you would use for, say, a standard carburetor application, and they're just riding in the hole just enough. I'm getting a very close enough measurement through this nice square, and I'm making sure that I can adjust these studs in and out and get almost the exact same reading. And I'm going to just redraw those areas where those studs are so that I can re-drill them, and I shouldn't say redraw them and drill them in the right place. and this sucker's just going to slap right on. Thanks for watching. And let's, now that I've shown you where I'm going to be drilling, probably should have made that into one video, but what the heck. I'm going to drill these out, and what I'll do then is take the longer studs that I have and fit them up onto that adapter piece, put them through the bottom, and then take a gasket and take that AFB that I told you I had. I'll stick that on top of there, and we'll see if everything's working out like it's supposed to be working out. Let's do it. Okay, so we've got all the 4 holes drilled. Let's take one quick test run at it. I'm sure we'll need a little bit of reaming, but they're right there. Okay, so what we're going to do is, let's see, what size ream did I snag for this? It's 21/64, so it's a few thousandths of an inch bigger than the 5/16 hole. And you don't want that to be dead nuts tight around your studs, because this stuff has to expand. You know, it gets hot, it gets cold, it's going to move around in difference from other pieces of the engine. So there's always going to be a little bit of give in there. And that's a few thousandths of an inch, so it should do the trick. It's been a long time since I've done any of this kind of work, so let's make sure we get plenty of goo on there, right? And that's what I like about the A9, is that it's a little thicker. The Tap Magic is good stuff, but it does run out pretty quick. Alright, so let's see what we can get. Already my little device doesn't want to work. It's because I got something stuck in there. Probably like my big toe. There we go. Okay, so we just kind of gently work that in there. A little back and forth. Almost like a regular tap and die set. A little downward pressure. And you got to remember, every few turns, you got to pull that baby out. Take the cuttings out of that flute. And then back you go. Alright. Welcome back. As promised, I'm going to fit the carburetor on there and make sure everything's going to work fine. And I made a little mistake. It's kind of a rookie mistake. I knew better than to not catch something that I was doing, but it doesn't matter. It's not going to affect the operation of the unit. Just probably affect my ego a little bit. So let's get to it. Now I am glad that I decided to dry fit this, especially with an AFB. I was always curious about just how far out I had to go before I interfered with some linkage or parts of the carburetor that were sticking out. So I'll be handling some of that in the detail work, but the linkage will need some room to drop down. So not all of this was going to be here anyway, but it will change a little bit of the looks. I don't think it's going to affect the outcome of the performance. And there you go. Now, obviously my my studs are not long enough, but they all go through. Looks good. Runs fine. Probably lasts a long time. I don't see any issues on the other side. But I'll make sure there's a relief cut back, just in case there are. So that's it. We'll now turn to the forming of the cooling portions. I know you think that that's what that is, but that's not. Everything is going to be cooling that way. So I'll start taking care of that in our next series of videos. Thanks again for stopping by. Well, hello neighbor who isn't Tim. Say, have you seen Unfinished Project lately? I'm just reading. Hi neighbor who's not Wilson. No, I haven't seen him at all. Say, what's that book you've got there? Well, if we knew what he looked like, maybe we could, you know, see him. But we really don't know what he looks like. So I'm just doing some reading to follow along with LD Bruins and what he's doing with the spacer plate for Just Mopar Joe. I find it fascinating. Stream of air blowing across the lip of an organ pipe sets up whirlwinds along both sides of the partition. It's right there. It's physics. Gotta love it. Well, thanks, neighbor who's not Tim. We'll see you soon. Why, that's amazing. Well, thanks for sharing that with me, neighbor who's not Wilson. See you soon. Back. Today, I just kind of wanted to show everybody who hasn't worked with this kind of a project where the stock is so huge, much bigger than the machine that you've got to deal with it. How I chopped this thing up into little pieces. So, well, I shouldn't say little pieces. I chopped off little pieces. And basically, that's just so I can save myself some time. And I also wanted to address something that Just Mopar Joe was talking to me about the other day. And that was one of the little secrets I've got built into this. The other day, a week or so ago, you may have seen the little funny piece I did on Ware's Unfinished Project, the YouTuber. I also threw in a big clue. And that clue is about the process of where a pipe organ works, where air brought across one side of a chamfered opening also creates an equal disturbance on the other side. So a lot of, well, I shouldn't say a lot of, there are some spacer plates out there that try to create this effect at the bottom when they have like a twisting, I don't know what you call it, it's just it's a piece at the bottom of their spacer plate that has a design that looks like it'll twist the air as it's coming through it. So, and it gives you a vortex going into the manifold. I don't know that they're getting the best. I like the idea. I don't know if they're getting the best out of the idea by separating it sometimes into 4 holes. Like, because you've got a 4-barrel carburetor. Why not just take the entire space that you've created and make that space twist? So that, and being straight up and down, it may be a little tougher to do that give yourself a few degrees of a slant. And that's just what I've done. I created like a 3-degree slant inside of this spacer. So what my goal is, obviously, is to prove the theory that that can actually work by slanting them off the dead center and at the same time having the walls of the spacer inside create this vortex. And now the whole vortex underneath that opening into the manifold starts to move the air around equally and not kind of divided up into little, who knows. I can't tell you if they've ever really proved that or not. But anyway, let's get to that. And maybe by the time you see this video, I will probably have this very close to being shipped to Just Mopar Joe. So I mean, these videos are kind of spaced out a little bit. And let's get to it. Now, if you've been following around from the other videos, you recognize what these are. So those were just cutoff points, right? Literally just drilled off and then hacked off sections of this big, huge piece I didn't need. Same thing here. I drilled, like 3 holes, enough to get the reciprocating saw blade down in there, and then just come down along the side of where I'm going to be milling out the fins. Same thing on this side. So you can see the pretty much the contour of that as that's going to take place. And I think I left enough. I was very careful to have like a boss to get some screws and put on a shroud, because I'm also going to have venturis cut through the unused area here. 4150 might have, usually sometimes they have 2 holes on each side, but since he only uses the outside holes, I'm going to use this to create venturis down through the front, so that it's going to grab that air coming through, and then it'll come passing along these fins that I'll have drawn out in here. Hopefully I'll be able to get some in the back to go back towards underneath that carburetor, under the back bowl, and shooting out towards the distributor. And that's how it's shaping up. So like I said, now I'll probably have to go back and re-blue this and rescribe some of the lines just so I can see what I'm doing, because I'm getting old. Alright, thanks for stopping by. You'll enjoy watching what I consider to be just kind of, hey, today we're doing a little video on, I'm just cutting some of this stuff off. And I did here on one of the workshop videos, or workshop streams, that some of you guys wanted a little longer video, some wanted a little shorter video. Most of my videos are pretty short because I tend to spend more time with the tools and not with the video camera. So today I've shot a couple of them, and one very long one. This is the very long one, and hopefully you'll enjoy watching what I consider to be just kind of easy work, like cutting the grass, taking something rough and crude and making something machined. So anyway, let's do it. that. So anyway, we'll go juice and we'll kick it back on. Hello. Okay, so let me make another pass back at it. And see if I can't get the controller to stay with me this time. The vibration's so hard that it's knocking the controller out. Matter of fact, I think I just left it to side axis. So now you've seen me just cut out that dog ear. Of course, I come at it with you know, a Dremel tool, smooth it out. But from here back, I have to cut it for the fluted cooling fins. I'll be going this way. Don't try this at home on a drill press. The drill press arbor is not strong enough to handle that kind of load. This small machine is a small machine. It's not like a great, wonderful Bridgeport or one of those big CNC boxes. However, for light stuff or once in a while, crazy stuff like this, it's a great thing to have, and I've always enjoyed it. Well, thanks for watching. I know it was long. Some of you guys wanted a long one. I hope that was long enough. Take care. And welcome back. Another day of milling. Just lots and lots of milling. It's a lot of fun, you know, creating something. So I'll just show you some more. A couple of days worth. Let's get to it. Oh, got that other dog ear cut out for the mounting bolts. So it looks good. Just needs a little fixing up with the Dremel. Then we keep going. Thanks for watching. Okay, another day of continuing on milling the one side. Now, when I was here last time with you guys, that would be the day before, I was milling down, or I began milling down for the cooling fins on what will be the, I'm looking at it now, driver's side. And I've made them in two different depths. And the top one is a little bit further away from the rest, and that's because I have to knock out a considerable amount of the top piece for the clearance of the carburetor linkage. You know, when you're putting the butterfly open and that big linkage is kicking around, it's going to lose a considerable amount of that top piece. So it's not that important, but the bottom ones are much more closer together, and hopefully that will give a lot more air, or should I say, give a better chance for the air to flow through and let those fins really drop the temperature. Now what I'm going to do is I'm going to angle drill the ports around and between the mounting holes and the throat itself in that area that's not used, and that's where the cooling jets will be put together so we can drive that air around the side and into the back behind the carburetor. Let's see what we've done, and let's do some milling. Alright, let's give it a go. See if we can't make one of these babies fly. Actually, I need to get a few things out of the way. And double check that. Okay. Now, I gotta clean those off before I go sticking them back in their positions. And by the way, I used a handy dandy T-square to scribe those lines. Oh, stand by. Here we go. I'm gonna lock that in, and I should probably make some passes higher up. Beat that up too hard. Let's start in the middle, see what happens. Alrighty, stand by. Come away a little bit more. I don't even know if that line is straight or crooked. That's something I should have checked. I did check it before, and it did look pretty good, but I don't know. Let's see. Well, Joe, if it turns out to be crooked, it'll still work. By God. It's working. I'm still going to pick her up a little bit. So, that's going to take a while. See you when I come back. Alright, I think we're going to have a little stopping point here for the day. One of my arbor guides came out, so like I was talking about earlier, I was going to have to respec this baby after I was done with this, so it looks like I'm going to have to do it ahead of time. So, well, let's stop for today, and anyway, we'll see what we're doing here. Alright, so it was starting to make a good cut. Well, good enough anyway. Good enough for government work. Alright. See you next time. Welcome back to the Airclaw 1 creation. And today I will continue on showing you the the completion of the vanes, and that's going to be pretty much the biggest part, the biggest chunk of what's done. So let me get on with that and perhaps put a few more videos together, and you will see before long what the finished product is. I did make an administrative decision, but I will go through all of that in my last video with this. Throw in some pros and cons, throw in my impression of what I think these things can do, and as Tilly Savalas would say, like that. So let's get on with it. So I've got my one side scrawled out here. I don't think you can see it, but the other side is scribed out. And just like the other side, I'm going down a standard depth up to this point, and then I'm going to raise it back up to give me plenty of clearance around this back mounting hole, and then continue on right through to the back. So we'll just kick on a little bit here, and on the next video you'll probably see me having drilled holes and so forth and so on. Alright. So I leave you with some noise. Have a good weekend. One more thing. I'm making these initial passes with a flat end mill, and then I go back with that round ball end mill to cut the nice curvy groove that goes right through all of these tooling vanes. Okay, let's go to it. Nice and easy. Feel the vibration. It's okay. Nice and easy. Just like we're on track. That's right where I want it. Okay. See you next time. Alright, so here we can see the cooling vanes that I put in. And this is where I tell you the top one is a little bit further away. This is going to have to be milled off right in here. And then right down in there I'm going to put 3 diagonal drill holes. And 3 up in the front. And they will come out the other side. And that will be giving us some draft along with the cooling on the vanes on the side of the spacer body. So let me get the drill bit changed on there and see what happens. It certainly is coming along, that's for sure. Measuring exactly what kind of clearance we have. Got all the clearance in the world. Air Claw 1 coming together. Almost done. Well, the day's finally come. It's kind of like giving, I don't know, a new painting or a sculpture away, you know, or releasing it to the world. It's alive. No, we're talking about this 2 1/4 inch spacer. It's a spacer plate that I made from a design basically in my own head, and I like to say that this design is in the public domain now, after all of this. It's something that you might want to use on your car, but there is another idea I have for, let us say, better operating temperatures for the drag racer as opposed to this one, which probably works better on oval tracks or autocross type of racing. But aside from that, this thing should help give just Mopar Joe a little bit more of an edge. And some of you have seen him using the 2-inch plate recently, and I asked him to do that because that's as close as he's going to get to this 2 1/4-inch plate. So I want to make sure he's not running too lean, that he's going to be able to try to adjust any carburation issues long before he gets to No Name Nationals. So we're at the end of August, and it's time to let her go. But I'll show you some of the things that I did to it, and what we'll do is go right on back to the desk where I started this whole adventure with that big chunk of aluminum. You may remember this. 2 1/4 inches. 2 1/4 inches. So let's get back to it. And I also want to say thanks to John Wilburn and Dallas Brown, and of course Buzz up there at the Roadkill, and anybody else who's given me a thumbs up or subscribed to the channel, and those of you who I've met along the way. It's been really good. It's been fantastic to see the generational transmission of old school backing up the new school. So let's take a look and finish this up so I can get it off to just Mopar Joe. Here we go. And here it is. I don't know if you can see it. It's very shiny. The Air Claw 1 with its veins. It's very, like I said, it's very shiny. Joe, I'm probably gonna run a little patch cloth here through the mounting holes, but make sure you, as you well know, when you get something back from the machine shop, you'll want to clean it up yourself, double check. So double check my work, please. Here's the initial shape. The black spaces here, the front dog ears I painted black, and not for any reason, just because visual effect. If the camera can see it, I elected not to do 3 ports on each corner. I elected to do 2, and that's because if in fact this generates a lot of disturbance behind the dog ear, which typically with that air coming off the front of the car may have a little vacuum here, and this is why I wanted to put these holes to eliminate that vacuum and fill this as a column of air to go across the fins and help cool down the back of this thing. The front, as you remember from Joe's initial readings that he took under the hood of the car, the front of his carburetor and spacer were relatively cooler, especially the intake manifold was relatively cooler than everything in the back, and that included the fuel line. Now I know he's changing the size of the fuel line, but just in case, what I did was that on that side of the hole, that side of the passenger side of the air claw, I brought the top port out a little bit, directing it kind of up and towards the back of the carburetor and the fuel line as it came into the carburetor here. Now, another thing you may not be able to see is I have 2 ports on each back corner. So this is where the claw comes in, where the section that has your mounting hole is elevated, so it acts like a set of fingers, and it's pulling in really hard on those veins, and that's going to generate as the De La Valle style valves or jets, generate some forced air in the back. And this is an area that generally probably has a vacuum when the car's going down the strip at 50, 60, 70 miles an hour and above. So this will help move the air behind it and hopefully get some air back underneath the float bowl of the carburetor. And what happened the other day was one of my YouTube subscribers, Tim62, geez, Tim, I'm sorry, they beat me over the head. You know what, let me look it up, because I think it was the right guy. Or just when you want your own page to come up, it's never going to come up. So, hey, bear with me. Yeah, Tim's 72 Demon, if I remember correctly. I could be wrong, but I think it was Tim. Said I should get this engraved. I said, yeah, that's not a bad idea. I kind of had the same feeling about it. And there was an engraving shop in our town. Little did I know the way things have been in the last 2 years. Not only did that shop close, a gun store closed, and a bunch of other stores closed that were in the same complex. So I was so put off by that, I said, the hell with it, I'll bring it home and use my my Dremel and scratch it in. So that's what I did. I scratched it in Air Claw 1, and then I took a Sharpie, which is also one of Tim's ideas, and I kind of outlined it in black. I know that's not going to be permanent, but that's what happened there. So I also decided to give it, let's see if you can get that, I don't know. Maybe you can anyway. I attempted to punch just like you would punch numbers on engine parts, because I've got those punches. NNN 2022, so that would be No Name Nationals 2022. And down below it I have the serial number of this particular unit, that is XX1. And on the top and the back I tapped in the word top, so it's very small, but Joe, so when you're looking at this thing, just know, that's top. Tells you where the top is. The clearances were okay on the AFB. Hopefully that'll be the same on the 4150 style. I don't have a 4150 base plate. All I had was the adapter for one of those. So, Joe, if you get this and any of the linkage gets in the way, you can drill this stuff or mark it off and grind it. You just grind it off, do whatever you got to do to make it fit, and make sure you, and this isn't just for Joe, this is for anybody who would try this. Make sure that that carburetor sits on there and everything opens up freely, that there's no problems with any of the throttle plates popping open. So I think that'll about do it. I do have, let me see, I've got some specialty washers, and if you've, actually I've got the book right here, What Do You Know? And just to prove it, even David Vizard speaks about that in his book, to keep things cool, like the carburetor. If you really want to go after it for the little stuff, you're going to want to use some kind of a non-conducting thermal washer between the base plate of the carburetor and the mounting nut. So what I did is I sourced some very special washers. They come from a company called McMaster, and these are made in the United States. One set are mil-spec plastic washers, and they have a hardness that's right about, the shore hardness is about 55D, and they are good for chemical resistance and good to 500 degrees Fahrenheit. So I'm throwing those in. There's also a different set. Yeah, oh yeah, by the way, Yeah, here it is. McMaster car. So that's where I got these from. No, they didn't pay me any money to say that. So here's the black ones. These are chemical resistant, and they have also an ASTM. This particular one, ASTM standard, met by stainless steel washers, but they're plastic. These are plastic, and they're good to 450 degrees Fahrenheit. So Joe, you can try either one, but we'll need you to take some very specific readings when it comes to that. Don't you go running any moonshine. That stuff's illegal. Don't mess with it. So Joe, I'm going to sign this for you. This also was Tim's idea. So let me sign it. And LB Bruins 79. There it is.